Alright, I'm back. So we're at question number 7. And so you're given this position equation. The question is, at what time will the pebble hit the ground? So the position would be 0, and then we solve it. So I'm going to subtract 600. A little blurry, right? Let's see if I can make it not. There we go. Divide by negative 16. So a negative divided by negative is positive. 600 divided by 16. I don't know what it is. You got to use a calculator. So when you take the square root, the answer is only positive because it's a real world situation. So I could reduce it down. I didn't think it went in evenly, so that's why I was kind of looking around. And then what is the square root of that? 600 divided by 16. Oopsie. And there you go. So 6.123. And that is in seconds. For part B, what is the pebble's velocity when it hits the ground? So the velocity is the derivative of the position. So 2 times negative 16, negative 32t, the derivative of 600, 0. Then you plug in 6.123 and use your calculator. So I'm going to go negative 32. Now I'm going to be really accurate. So I'm going to actually plug in the square root of 600 over 16. That gives me super accuracy. And I get negative 195.959. Whenever you can be super accurate, it's best. And the units are in feet per second. So when it hits the ground, it's obviously, the negative means what direction it's going. See, what is the pebble's speed when it hits the ground? Well, speed is the absolute value of that. So positive 195.959 feet per second. All right, turn the page. Number 8. Don't use a calculator. Oh. All right, I won't use a calculator. All right, take the derivative. Step 1 is to make this calculus friendly. So we're going to write this as 3x to the negative 3 and then take the derivative. So the derivative of 2x, negative times the negative is positive 9. Subtract 1 to the exponent. So it's 9x to the negative 4. Number 9. I'm going to multiply it out. So I'm going to FOIL it. That's 4x squared. 6 and 6 is 12x. And then 3 times 3 is 9. Then take the derivative. That's 8x plus 12. Number 10. Alright, for number 10, I'm going to write this calculus friendly. That's x to the 1/2. And then we multiply it together. We add the exponents when we multiply it together. That's 1 plus 1/2, 3 over 2. Now, take the derivative. So 3 over 2 times 2, the 2's cross out. And then subtract 1 to the exponent. Remember, it's 3, take away 2, so it's 1 over 2. And then we have to evaluate it. Now I only need the x coordinate, so that's 4. So I evaluate it at 4. This means the square root of 4, so that's 3 times 2, so the answer is 6. Number 11. Again, I'm going to write it calculus friendly right away. That's x, and the exponent would be 2/3. The derivative of that would be 2/3 x to the negative 1/3. And then the derivative at negative 4, or negative 8, I mean. Now, a couple things here. The cube root of a negative number is still negative. The cube root of 8 is 2, but it's the reciprocal. So this negative exponent means, okay, the cube root is 2, but it's the reciprocal. Then the 2's cross out, and you're left with negative a third. Number 12. I'm going to multiply it out. That's x squared minus 2x. The first derivative is 2x minus 2. The second derivative is just 2. 13. Find the equation of a tangent line. So we have the function. So we know x equals 1. If I plug 1 in for x, it's 2 take away 3, which is negative 1. And then the slope, I need to take the derivative of this, 8x cubed minus 9x squared, and then I plug 1 in to find the slope. So it's 8 take away 9, so it's negative 1, and then put it all together. So it's y equals negative 1, x minus 1, subtract 1. A lot of negative 1's. 14. In number 14, find a point. Sometimes I think my camera kind of goes away from me, but here, I'll do it this way. All right. Find find a point. So the function is f at x equals x to the fourth plus 3. And it says the slope, so the derivative, is equal to negative 4. So the slope is negative 4 of the tangent line, so the derivative is negative 4. The derivative of that is 4x cubed, make it equal to negative 4. Divide by 4. Now the cube root here will be negative 1. So what number 3 times itself is negative 1? That's negative 1. So now I can know what y equals. Plug negative 1 in here, and you get 4. And then the slope is negative 4. What do we need to find? Oh, find a point on the graph. Well, that's the point right there. Negative 1, 4. 15. I use the limit. Do I have to? I use the limit definition to find the derivative. So the limit, as h approaches 0, it's x plus h, subtract, now it's the function, inside the parentheses, just over h. Let's do some algebra. We're going to expand and combine like terms. That's x squared plus 2xh plus h squared minus x minus h minus 3x squared plus x. We're now going to eliminate. So 3x squared and negative 3x squared, negative x and positive x. So 3 times 2 is 6x, and the h will be factored in front. 3 times h squared is 3h, and I take one of the h's and factor it in front. We have negative h, so that becomes negative 1 when you factor it in front. Now I can eliminate the h. Now I plug in 0 for h, and I get my answer. Number 16. F at x equals x cubed plus 5. Find the instantaneous rate of change. That's the IROC, which is the same as the derivative. So first I'm going to find the derivative, which is 3x squared. And then it says find the instant when x is 1. So then you plug in 1 and you get the answer. Number 17. The function is x cubed plus 5. AROC is y2 minus y1 and x2 minus x1. So what are the x values? 0 and 2. So we subtract those and then plug 2 in, that's 8 plus 5. Plug 0 in, and that's 5. And there's your answer. So 8 divided by 2, so the average rate of change is positive 4. Number 18. Use a calculator. Now we're talking. And we're going to take the derivative at 3. Let's do that. So how do I do that? I press menu, calculus, derivative at a point, and we want it when x is 3. And then you type it in, 7 to the x, and then go control enter, and you get 667.447, and there's your answer. Again, use a calculator for this. Let me show you each one. Okay, using a calculator. So first of all, how do you find the derivative at 2? So let's do that. Menu, calculus, derivative at a point. And then the value for the first one I said was at 2. And then we type in sine. Inside is going to be x cubed plus 4x cubed. And then control enter, and it's 46.253. Don't round. The next one is at negative 4. Now we already did all of that, so all I need to do is highlight over and then change it from 2 to negative 4. It's 210.809. And then how do I do a second derivative? Let me show you. So we're going to go menu, calculus, derivative at a point. It's at 1, right? Yeah. And then see this first derivative? Change it to second derivative. Enter. And now type it in. And you get 19.668. Perfect. Number 20. So looking off the graph, let me show it to you. Is f continuous here? Yes. So it's continuous at 0. There's no breaks or holes or nothing. So it is continuous. Will it focus on for it? So at 0 it is continuous even if it's not focused in. And then B, is it differentiable? And the answer is no, because of a sharp turn. So it's not differentiable, but it is continuous. For number 21, at 0, is it continuous? And the answer is yes, it's continuous there. And then B, is it differentiable there? And the answer is no. Why not? Because that's a vertical tangent. And that's a cube root function. 22. You have a function. And the question is it continuous at 0? So if I plug in 0 on top and then 0 on the bottom, I get the same answers. The answer is yes, because they both give you the answer 1. Is it differentiable? Well, I got to take the derivative. So this is 2x, and on the bottom is 2x plus 1. And the key is if I plug in 0, do I get the same answer? The answer is no. So the top gives me 0, but the bottom gives me the answer 1. So the answer is no. And again, the answer, because it's the derivative and it's continuous, it's a sharp turn. So there's no jump in the graph because it's continuous, but the derivative shows there's a sharp turn when they meet. 23, still on the same page. X squared plus 1 negative x squared plus 2. Is this continuous at 0? So plug in 0 and plug in 0. The answer is no. Is it differentiable? Again, the answer is no. Why? Because there's a discontinuity, right? So there's a jump in the graph. So because there's a jump in the graph, the derivative doesn't exist at that discontinuity. 24. Make it work. Alright, we're almost there. So we have x squared plus 1, negative x squared plus 1. Is it continuous at 1 or at 0, right? Plug in 0 and plug in 0 and the answer is yes, they have the same answer. Is it differentiable? It looks like the answer is yes. So when I plug in 0 and 0, I get the same answer. $25. This is a step function. Is it continuous at 0? So when I plug in 0, I get an integer. There's a jump. So the answer is no. Does the derivative exist there? The answer is no, because there's a jump in the graph at every integer. So when I plug in 0, because you have an integer answer, there's a jump. So it goes, this is what it looks like. So there's a jump there at 0. So that's why it's not continuous and there is no, I can't take the derivative. 26. All right, some graphing. Let's do this. So we have x subtract 1 squared, x squared plus 1, over x squared minus 1. Let's do this. Domain. So the denominator can be factored. So I'm going to do that. That's x plus 1, x minus 1. And then these cross out. And so I only have one x minus 1 on top. And there's no more on the bottom. So what I just crossed out on the bottom creates a hole. But first of all, we can write down that x can equal positive or negative 1. And then what I just crossed out, the 0 of what I crossed out is positive 1. And if I plug positive 1 into here, I get the answer 0. What's left is a vertical asymptote. That's at negative 1, and it's odd. X squared plus 1, there's no zeros that come from it, so there's no x-intercepts. If I plug in 0 for x, there is a y-intercept. That's negative 1 divided by 1. And we're going to do that. So at 1, 0, there's a hole. At negative 1, there's a asymptote. Oh yeah, the end behavior too, right? But we'll do 0, negative 1. And then the end behavior. So we know it crosses here. And it's going to go up. The right end is up. So if I do the end behavior, it's x squared times x squared which is x to the fourth, and the power term on the bottom is x squared. So when I divide, it's x squared, so both ends are going up. This is an odd asymptote, so one end goes down, one end goes up, and then the end behaviors up to the left and up to the right. So there's a sketch of what the graph looks like. 27. We'll end with some limit questions. These are so important to review so you don't forget. So the limit as x approaches 2. When I plug in 2, it's indeterminate. So to remove the discontinuity, I'm going to get common denominators. So I'm going to multiply by x and by 2. So this is x take away 2 over 2x. Then I'm going to multiply by the reciprocal. Now it's removable. And then when you plug in 2, you get the answer a quarter. 28. The limit as x approaches infinity. That's an end behavior question. So if I look at power term over power term, notice power term over power term, divide, and you get the answer 1/2. 29. The limit as x approaches infinity. 2x minus 1 squared over x squared minus 9. Again, end behavior question. 2x squared is 4x squared over x squared. So the end behavior ends up being 4. Number 30. The limit as x approaches negative infinity. It's left end behavior. So when I look at power term over power term, it's 3x squared over x, which is just 3x. That's that line, so the left end behavior goes down to infinity. 31. The limit as x approaches negative infinity. So the square root of x squared, again, it'd be positive or negative x over x, which is positive or negative 1. To the left, when you plug in negative numbers, a negative divided by negative, it's going to go to positive 1 to the left. So as you put in a negative number divided by negative number, the other direction would be negative 1. So it's positive 1 for 31. 32, we're almost there. The limit as x approaches 2, this is a step function. So just plug in 2. It's not an integer answer, so it exists. So we're looking for the greatest integer less than or equal to this, so it goes down. So the answer is 5. The limit as x approaches 3 to the left. So if I plug in 3, I get 3 divided by 3. That's 1 plus 5. 6 would be to the right. So when it's to the left, you have to go down one step. So this answer is 5. 34. The limit as x approaches 3. And it's a two-sided limit. So when I plug in 3, I get an integer answer. So at 3, there's a jump, and the limit doesn't exist at a jump unless it's one-sided. And the last question. Find the values of a and b that make it continuous. So we're going to plug 1 into the top. That's 2. And then we're going to plug 1 into the bottom for x. That's 1 squared plus 1a plus b. So if I subtract 1, a plus b equals 1. We're going to do the same thing for 3. Plug 3 into the top. That's 4. Plug 3 into the bottom, that's 9, and 3a plus b. Subtract 9, and it's negative 5, and it's 3a plus b. So I'm going to subtract to eliminate. That's 6 minus 2a, so a is equal to negative 3. And then go back. This one's probably the easiest one, right? Solve for b. So plug in negative 3 for a, add 3, and b is equal to 4. Those two values would make this function continuous. Mr. G Math, over and out. I'm proud of you for doing your work. Until next time.